Hi, this is going to be a short video about what distributions to use for hypothesis testing. So the question we're going to answer in this video is, which distribution do I use? If you are testing for a single population mean and you know the standard deviation, then you use x bar is distributed normal mu sub x, comma sigma sub x over the square root of n. If you are testing for a single population mean and you don't know the population standard deviation, then you're going to use the student's t-distribution with n-1 degrees of freedom. The population parameter is mu sub x. That's the population mean. That's what we're trying to estimate. And the point estimate we're going to use for mu sub x is x bar, which is the mean of the sample. If you are testing for a single population proportion, you're going to use p hat is distributed normal p, comma, square root pq over n. All right, so the population parameter here is p, the proportion of the population, and the point estimate for p is p hat, which is x over n, the number of successes over the sample size. Let's talk about each one of these just a little bit. So for a single population mean with a known standard deviation, you need to make sure that the data is from a simple random sample from an approximately normal distribution, or at least a large enough sample size. How large is large enough? Well, in this class, we won't really make you answer that question. You do need to have a known population standard deviation to use this. If you're testing a single population mean with an unknown population standard deviation, you're going to use the student's t-distribution. Again, the data must be from a random sample of an approximately normal distribution. The sample standard deviation must approximate the population standard deviation. So from the sample, you'll compute S, the sample standard deviation, and use that in your computations. Finally, if you're testing a single population proportion, so like what percent of the population has this feature or that feature, you're going to use a normal distribution. You need to have the data from a simple random sample, but the underlying distribution this time needs to be binomial, all right? So there must be n trials of this with a probability of success as p. Each trial must be exactly the same, have the same probability. The sample size needs to be big enough so that the binomial is similar in shape to that of a normal distribution. How big is big enough? We have a nice figure for you here. If you take the sample size times p, it should be bigger than 5. And also if you take the sample size times q, remember that's 1 minus p, that also should be bigger than 5. All right, well, this is just a little bit about which distribution to use when.